All right, assalamu alaikum everyone. I hope you guys are all well. Let's begin then. So today we are going to talk about how to solve quadratic equations using different methods, and we'll also briefly talk about how the graphs of quadratic functions look like. Okay, so these are a couple of things that we will talk about, and while we are in the process of that, while we discuss how to solve quadratic equations, we will also learn how to complete the square for different quadratic functions. Okay, so in the last session, we talked about factorization, how you can factorize a number of different types of expressions. We did a number of examples on that. So these are some identities that you need to know of. And then we did some examples when we had to factorize expressions involving 2 terms, 3 terms, 4 terms. When you have 2 terms, generally what you do is you take something common, if that's possible, or you think of this identity if that can be used anywhere by converting the expression to form a square minus b square, and then a plus b into a minus b. Then we talked about how to factorize expressions with 3 terms. In this case, mostly what we have to do is we have to break the middle term if that's possible. Uh, before that, we can also see if something can be taken common outside. If not, then we see if the middle term can be broken. Now we will be using this today to solve quadratic equations as well. Okay, and then apart from this, we looked at factorization when we had more than 3 terms as well. In particular, when we had 4 terms, in that case, uh, you generally take something common from the first 2 terms and something common from the last 2 terms, and then the expressions inside the brackets, they turn out to be the same, and then you can take that common again to write a factorized form like this. Sometimes in this case, when you have 4 terms, you cannot take anything common from the first 2 terms or the last 2 terms directly. In that case, what you have to do is you have to sometimes rearrange the terms. Right? In this example, for instance, we brought a minus 8y(s) here, and we took 4z(s) here. We rearranged the terms, and then after we were done with that, we could take something common from the first 2 terms, and we could take something common from the last 2 terms as well. Okay, so this is what we talked about in the last session. And briefly, we talked about how to solve some equations as well using factorization. We will revisit this today. So when you have 2 factors like this, and they're multiplying, when you factorize the left-hand side already, then we use this idea that when you have 2 expressions multiplying and the result is equal to 0, that necessarily means that one of them at least has to be 0. So if you have a product, you have 2 things multiplying, x minus 3 and x minus 4, and the product is giving you 0 as the result. That necessarily means either the first bracket has to be 0 or the second bracket has to be 0. So that means we can split it into 2 parts and write it like this: x minus 3 equals 0 and x minus 4 equals 0. And that gives us 2 solutions for that equation. Right? We did some examples on this, and then we basically talked about this as well, that when you don't have 0 on the other side, then we cannot do the same thing as before. So for instance, when you had 0 on the other side, we could just equate each of the 2 factors equal to 0 separately, but we can't do the same thing when we have some other number apart from 0 on the right side. In this case, we cannot say that x minus 2 is equal to 4 and 2x plus 4 is equal to 4, because in this case, it's not necessary for one of these numbers to be 4. If the product is 4, we can think of a number of other examples that will give us 4 when multiplied, and none of them in which none of them would be 4. For instance, if I multiply 0.5 and 8, that also gives me 4. So it's not correct to assume that any one of them has to be 4 necessarily. So we can't solve equations like these directly like this. In this case, what we do instead is we take 4 to the left side, We first expand the left-hand side and take 4 to the left side as well. And then we solve it like a normal quadratic. This is what we discussed in the last session. Now, today, we want to talk about solving quadratic equations in a bit more detail. And in addition to that, we'll also talk about how the graphs of quadratic functions look like. Okay. So let's start with quadratics. That's what we would want to do today. Okay, now first of all, we want to understand how to solve quadratic equations by factorization. Okay. Again, we have talked about this in detail in the last session, so I'm not going to spend too much time on that, but let's do a couple of examples very quickly on how you could do this. For instance, if you had an equation like this, let's say you've got 2x squared, you want to solve 2x squared plus 3x minus 2 equal to 0 using factorization. How would you do this? You would see how to factorize the left-hand side. Now look at the left-hand side. What we do in this case is we multiply these two numbers, 2 and 2. What does that give us? That gives us 4. And now we think of the factors of 4, which could be 1 and 4, and it could be 2 and 2. And now we think of if we can use any of those factors and such that when we subtract them, we have a negative sign here, right? So when we subtract them, we get this middle number. Now look at this set of numbers, 1 and 4, for instance, we could say 4 minus 1, that gives us 3. So that works. We can break this middle term like this into two parts. We can say this becomes 2x squared plus 4x minus x, right? 4 minus 1. And then we've got this constant term as it is, minus 2 equal to 0. Now we look at the first two terms. We can take 2x common from this, and that gives us 2x into x plus 2. Look at the last two terms. We can take minus 1 common from this. Whenever we have this term negative, we always take minus common in that case. So in this case, we can only take negative common, so we can write it as minus 1 outside, and then inside the bracket we have x plus 2. And now since we've got the same expression inside the bracket, that kind of confirms that this working is correct. And now we've got this one term and this second term. In both of them, x plus 2 and x plus 2 are the same. So now what we do is we take x plus 2 common, and that leaves us with 2x minus 1 in the other bracket. And this is the factorized form. And now, since these two factors, when multiplied, give us 0, that means either x plus 2 has to be 0 or 2x minus 1 has to be 0. The first one gives us x equals negative 2, and the other one gives us x equals 1 over 2. This is how we can solve equations using factorization. Okay. Let's take another example. Let's say we had something like this. So again, we have to do this using factorization. Let's say we had an equation that looked like this instead. X squared minus 7x plus 10 equals 0. How do we solve this equation? Again, we multiply the coefficients of the first term and the constant term, which is the last one. Now, the first term has no coefficient. That basically means it's 1. So we multiply 1 and 10 and see what that gives us. That gives us 10. Now, think of the factors of 10. You can have 1, 10. You can have 2, 5. And that's pretty much it. Now, this is plus sign. You need to see if any of these factors, when added, give you this middle number. Well, 2 and 5, they give you 7. 2 plus 5, that gives you 7. Now, since you want negative 7 here, you can think of it like this, that it becomes minus into 2 plus 5 equal to negative 7, which is minus 2 minus 5, right? So what we have to do is, we have to break the middle term down into two parts like this, so that it becomes minus 5x minus 2x, and then the rest of the terms are written as they are. And now, what can you take common from the first two terms? You can take x common, and that leaves you with x minus 5 inside. You take minus 2 common from this, and that leaves you with x minus 5 here. And you've got the same expression inside the brackets. You can take that common, x minus 5 into x minus 2 equal to 0. And that leaves you with two solutions again. two equations again, x minus 5 equal to 0 or x minus 2 is equal to 0, x equals 5 or x equals 2. These are the two solutions that we get for this quadratic equation. All right, so this is how we can solve equations using factorization. So the same process that we learned in the last class, how to solve equations using factorization, we can how to factorize expressions involving three terms. We can use that same process to factorize the left hand side first of all, and once we're done with that, all we have to do is equate each of those factors to zero individually, and that will give you two solutions. This is one way of solving quadratic equations. Okay, make sense? Now let's talk about other possible methods for solving quadratic equations. Sometimes you have equations that cannot be solved using factorization. For instance, let me write down another equation here. Let's say you've got something like this. We want to solve this quadratic equation. 3x squared minus 2x minus 8 is equal to 0. Okay. Now, how do we solve this quadratic equation? We can again think of whether we can use factorization. 3 and 8, let's multiply them. That gives us 24. What are the factors of 24 that we can use here? 124. Okay. Then we have 2 and 12, 3 and 8, 4 and 6. Right? These are all the factors that we can use. Now, we've got a negative sign here. That means we want to think of two of these factors that we can use that will give us the number in the middle here. Well, in this case, we actually can factorize this. Okay, let's do it using factorization first and see what that gives us. So in this case, 6 and 4, they actually work. So let's do it using factorization. Then we'll do another alternative way of solving the same equation using another formula. Now, in this case, it's 4 and 6. And they, when subtracted, are giving us 2. So we can say 4 minus 6. Since we want a negative 2 here, we can say 4 minus 6, that is negative 2. So we can break it down into two parts like this. We can say this is 3x squared plus 4x minus 6x minus 8 equals 0. And then we see if we can take anything common from the first two terms, we can take x common. That leaves us with 3x plus 4 inside. And then we can take minus 2 common from the next two terms, and that leaves us with 3x plus 4 inside as well. That means our factorization is valid. We can write it as x minus 2 into 3x plus 4. And that means either x minus 2 is equal to 0 or 3x plus 4 is equal to 0. The first one gives us x equals 2, and the second one gives us x equals minus 4 over 3. Okay, now this is how we can solve equations using factorization. Now, sometimes factorization is not going to be possible. For instance, if I were to just change this equation slightly so that it becomes something like this. So I'm just going to change this slightly. And now instead of having a negative 8 at the end, what if I had a negative 10? Okay, now what about this now? How do I solve this equation? Let's think about it. Let's see if factorization can work. 3 times 10, what's that? That is 30. What are the different factors of 30 that we can try? We can try 130, okay, 215, 310, 4 doesn't work, 5, 6, and that's it. And we have a negative sign here. That means we have to subtract one of these set of factors such that it gives us the number in the middle, which is 2. Now, how can we get that? Well, it's not possible, right? This is giving us 7, this is giving us 1. 2 is not possible. So this equation cannot be factorized. Now, when an equation cannot be factorized, what's an alternative for us? We have a formula that we call the quadratic formula. We can use that to solve that equation. Now, In IGCSE or O levels, when you get this question in the exam, the question is kind of going to give you a hint that you have to use the quadratic formula. Now, what is that hint going to look like? They will say something like this. They would say, solve this equation, giving your answers correct to a certain number of significant figures or a certain number of decimal places. So they will tell you how many decimal places you have to write down in your answer and how many significant figures you've got to write down in your answer. Now, in the previous questions that we have done, we always had solutions that were either integers or they could be written as fractions, right? Either integers or fractions. When a quadratic equation cannot be factorized, the solution is going to be something in terms of decimals. Okay. So they will always tell you the level of accuracy you have to give your answer, that you have to have in your final answer. So for example, in this case, they might say you have to give an answer correct to 3 significant figures or 4 significant figures. They might write something like this here. Now, that's a hint for you since they want an answer that's going to be in decimals. Factorization is not going to work here. Okay, factorization is not going to work here, and you will instead have to solve it using quadratic formula. Okay, so that's what we do here. Let's see how we can solve this equation using quadratic formula since factorization is not working. Now, this is what the formula looks like. X equals minus b plus minus square root of b square minus 4ac divided by 2 times a. This is a formula that we can use directly to solve any quadratic equation if it is solvable. Even if we can factorize an equation, we can use quadratic formula in those equations as well. It will still give us a solution. But if an equation cannot be factorized, then this is the alternative that you have, that you use this formula. Now, how does this formula work? In order to use this formula, your equation should be in this standard form: ax squared plus bx plus c equal to 0. That means the coefficient of x squared, we call that a, the coefficient of x, we call that b, and the constant term, that is c. Okay, and now all you have to do is input values in place of a, b, and c here. Now, look at this equation that we've got. This is in the standard form. Ignore the negative sign. It doesn't matter if you have a plus sign there or a negative sign here. The values of a, b, and c will become positive and negative accordingly. So if you have negative number there, they will take negative signs. So for instance, this is the equation 3x squared minus 2x minus 10 equals 0 that we want to solve. Now, how do we solve this? We already checked factorization is not working. What's the value of a in this? The value of a is 3. The value of b is negative 2, the coefficient of x. And c, the constant term, is negative 10. Now, all we've got to do is input values in this quadratic formula: minus b plus minus square root of b squared minus 4ac divided by 2 times a. Now, it's not necessary to write down the formula, but it is necessary to input values in this formula. It should be in your working how you're inputting values in the formula. Okay, so you have to show that step in which you're inputting values in the formula. Let's do that. B is negative, so this is going to be minus into minus 2. Make sure that you're using brackets here, otherwise that will make you do errors. Plus minus square root of, again, b should be in brackets. Any negative numbers, at least, they should be written inside brackets. Generally, I would recommend that you write all numbers in brackets. That makes sure that you are not doing any careless errors. B squared minus 4 into a is 3 into c, which is negative 10, whole divided by 2 times 3. Okay. And now you've got to simplify this. Minus into minus 2, what does that give you? That gives you 2 plus minus square root of minus 2 whole squared. What's that? That is 4 minus 4 times 3 times minus 10. Minus and minus, that becomes plus. And then 12 times 10 is 120. You can do this on your calculator as well. So you will only get this particular type of equation in paper 2. So in the calculator paper, okay? Paper 2 for O level, paper 4 for IGCSE. You will not get quadratic equations that can only be used only be solved using quadratic formula in paper in the non-calculator paper generally, because if you have to give your answers to a certain number of decimal places or significant figures, you would not be able to do it without a calculator. So this generally comes in the calculator paper. Okay, now what do you get in this case? In the denominator, you've got 6. Now you can split it into two parts. This is plus minus. Okay, so you can write it like this. You can say this is 2 plus square root of 124 divided by 6. And the other part is going to be 2 minus square root of 124 divided by 6. And now you can write down your answers. You have to show at least a few steps. This step is absolutely necessary. If you don't write this, you don't get marks. But then at least show some working. It's going to be a 4-mark question generally. So they do require you to show the steps in your working. And now you can put this on your calculator to see what you get. The first one, 2 plus square root of 124. Write it exactly like this in the calculator. And the first solution that you're getting is 2.18925. The question says you have to give an answer to 4 significant figures. So the first one is going to be 2.189. And the second one, just change the plus sign to minus sign. And that gives you minus 1.52. Now be careful, it's 258. So the third decimal place is going to be 3 here. And that's the two solutions. These are the two solutions to 4 significant figures. All right. That's how you use the quadratic formula to solve quadratic equations. Now, to verify your answers, I would highly recommend that you know how to use the calculator function to solve quadratic equations. Okay, because that will be helpful to verify your answers. In this case, so if you have a calculator like this, what you can do is you can go to menu and go to the equation solving function here. It's after number 9 here at number A. I select that. Then quadratic is actually a category of polynomials. So we select polynomials here. And then degree means the highest power. It's a quadratic equation. Quadratic equation has a highest power of 2. So we select 2 here. And now all we have to do is just write down the coefficients of this equation. So the first coefficient is 3. We input that here. The second coefficient is -2. We input that here as well. And then the constant term is -10. We input that here as well. Now press the equal to button, you get your first solution, which is 2.189. You can see that that's what we got here. Press the equal to button again, you get the second solution, and that is -1.523. That's the other solution that we were looking for. Okay, so these are the two solutions that we've got. Now, since they have included surds in your paper as well, it is possible. So we'll talk about surds later on in a bit more detail as well. But it is possible that they give this in paper 1 now as well, in the non-calculator paper now as well, in which they ask you to write down your final answer in a form like this. Now, what would you do in that case? You would have to simplify this a bit further. You have to simplify this and you have to simplify this in case that is possible. Otherwise, you just leave it as this as the final result. But in case it's possible to simplify this, you would have to simplify this. Now, how will that work? The square root that you've got, you will see if you can simplify that any further. So this is square root of 124. Now, if this is in paper, if it is in the calculator paper, you can do the simplification of the square root directly on your calculator. Okay, I'll show you how to do that. But if it's in the non-calculator paper, you'll have to do it by hand. How do you do that? You basically remember all the squares, right? The square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 25. Think of all the squares that you've got, right? And so on. And now you find from these numbers and see, is any of these numbers a factor of 124? So amongst these numbers, find the largest number that is a factor of 124. Okay, let's start from the right hand side. 64 is not a factor. 49 is not a factor. 36, is that a factor? 36, 72, 108, no, it's also not a factor. 25 is not a factor. 9 is also not a factor. 124 is a factor. 4 is a factor of 124. Now, what you do in that case is you write 124 as 4 times something. Okay, now 4 times what? 124 divided by 4. 12 times 4 is 3, so that's 3. And then 4 times 4 divided by 4 is 1, so that's 31. We can write it as 4 times 31. Now, why did we choose perfect squares here? Because now what you can do is this perfect square that you had, you can write this as 2 squared times 31. And now this number can actually go outside the square root, because the square and the square root, they will get cancelled just for 2. And we can write 2 outside so that it becomes 2 times square root of 31. So that means we can simplify square root of 124 to 2 square root of 31 so that it becomes 2 plus 2 times square root of 31 divided by 6, and this becomes 2 minus 2 square root of 31 divided by 6. And now what you can do is you can take 2 common from the numerator, so it becomes 1 plus square root of 31 divided by 6, and 1 minus square root of 31 inside the bracket divided by 6. Now 2 and 6, they can be cancelled out, and they give you 1 plus square root of 31 divided by 3 and 1 minus square root of 31 divided by 3. And in case they want you to give your answers in surd form, you would write it like this. And if they want you to give your answer in decimals, in that case, you would stop at this point and won't do any further simplification. Put this directly on your calculator and write down the decimal numbers as the final results, and that will be the solution. So depending on what they ask in the question, you can do both of these workings. So in this particular question, they asked us to write down the final answer in decimals. So this is what you would do in this particular question. But if they asked you to give your answer in surd form, then you would do something like this. Let me write it here as an OR working. This is if they ask for answers in surd form. Okay. In this particular question, we would stop here. But if they were to ask for answers in surd form, we would have to do a simplification like this and not give an answer in decimal form. Okay, now we'll talk about surds later on in a bit more detail, how to do the simplification, but this is how it works for this particular problem. If it was in a calculator paper, the surd can actually be simplified directly on a calculator as well. Just put this number on your calculator and you'll get the result directly from that. Square root of 124, and your calculator will do it for you 2 times square root of 31. And then you can put that there and do the simplification after that. Okay, so you should be familiar with both of these, how to find answers in decimal form at the end, and also how to find answers in surd form like this. This is how we solve quadratic equations using quadratic formula. All right. Okay. Any questions until this point? Any quick questions until this point? No? All right. Now, let's go back to one of these equations. Let's say we had this one. Now, this was an equation that we solved there, right? And when we solved this equation, we got two answers from this, x equals 5 and x equals 2. Now, what do these values of x represent? X equals 5, what does that mean? X equals 2, what does that mean? What do these values of x represent? Now, number one, these values of x are basically the values that satisfy this equation. If you were to input x equals 5 there, the equation becomes 5 squared minus 7 times 5 plus 10. The left-hand side will evaluate to 0, and you'll get 0 equal to 0, and that means the equation is satisfied. Okay. Similarly, when you put 2 there, the equation will be satisfied for that value of x as well. So one understanding of these x values is that these are the only values of x that satisfy this particular equation. Okay, that if you were to input these values of x in the equation would be satisfied. Okay. There's another interpretation of these values of x, and that's a graphical representation. Now, this will come in handy later on as well when we do graphs of functions. So you should have some understanding of this right now as well. Whenever we are solving an equation, we're basically talking about two functions. We have one function on the left side of the equation, another function on the right side of the equation. So in this case, in this equation, we have two functions. The function on the left side is y equal to x squared minus 7x plus 10. This is one function that we have. And the function on the right side is y equal to 0. These are two functions that we have. Okay. And the solutions that we're getting from this, they basically represent the points of intersection of these two functions. Y equals x squared minus 7x plus 10 and y equal to 0. Now, what kind of function is this? What does the graph of this function look like? Let's talk about that first of all. Graphs of quadratic functions, and then we'll come back to this interpretation of those values of x, because that relates to the graphs of quadratic functions. Now, quadratic functions can basically have graphs of two, they can have two shapes as far as the graphs are concerned. The standard form of a quadratic function looks like this: y equals ax squared plus bx plus c, right? That's the standard form for a quadratic function. Now, there are two possibilities. One, that the coefficient of x squared is positive, a is positive, and the other, that the coefficient of x squared, a, is negative. These are two possibilities, right? When the coefficient of x squared is positive, you get a shape that looks like a U shape. The graph looks like this. And when the coefficient of x squared, this number, when this number is less than 0, that means when it is negative, the graph that you get is an inverted U, like this. Now, a lot of you would know this as a smiley face, the first one, and a sad face, the second one as well. You can remember it like that as well. But these are the two possible quadratic shapes that you can have. It can either be a U shape or it can be an N shape. These are the only two possibilities that you can have. Now, these graphs have some properties. Number one, they are always symmetrical graphs. So if you were to break these graphs in the middle, this is going to be a line of symmetry for these graphs. If you were to break them exactly in the middle like this, okay, this is going to be a line of symmetry. So the left side of the graph and the right side of the graph, they are reflections of each other in this line, okay? And this point here for the first graph and this point here of the second graph, these are important points on the graphs of these functions because they are the turning points. These points are called the turning points. Okay, these points are called the turning points. Now, in the first case, we can also say this is a minimum point. And in the second case, we can also say it's a maximum point. But both of these together are known as turning points. Okay. Now, these are important points on the graphs of these functions. We'll talk about these as well, how to find these turning points. Now, this is one important point on the graph. Then the other important points on the graph, when we sketch them later on, will be the x-intercepts of the graph and the y-intercepts of this graph. X-intercept is where a graph cuts the x-axis. Y-intercept is where a graph cuts the y-axis. Now, this number C here is the y-intercept of this graph. So, for instance, if you have this quadratic function, the y-intercept is going to be this value y equals 10. So the graph will cut the y-axis at y equals 10. What about the x-intercepts? These values that we found here when we solved those quadratic equations, these are actually the x-intercepts of the graph. Why? Because these are values when y equal to 0, this graph, and y equals this, these two graphs, they intersect each other. Now, the second graph, y equal to 0, is basically the x-axis. That represents the x-axis. So if you were to draw this quadratic function, the quadratic function, you see the coefficient of x squared is positive. That is going to be a U-shaped graph. It would look like this. The values of x that we have found here, they will represent the points where this graph intersects the x-axis. If this is your x-axis, this is basically the line y equal to 0. The points of intersection of this graph with the x-axis are going to be 2 and 5. So when we solve quadratic equations like these, where we have 0 on the right side and a quadratic expression, a quadratic function on the left side, the solution of this equation, the values of x that we get from that, they basically represent the x-intercepts of this graph. So these are x-intercepts of the quadratic function. Okay, so that's another interpretation of these solutions that we are getting from this. All right. I hope that makes sense. So how do we solve equations using quadratic equations using factorization? We talked about that. How do we solve equations using using the quadratic formula? We talked about that. And now the solutions that we get, what do they represent? They represent the x-intercepts on the graphs of these quadratic functions. That's what they represent graphically. Okay. All right. So on these graphs, now we know if we had to find the y-intercept of the graph, that would just be this constant value. So if I were to write down a random quadratic function here, let's say I have y equals 2x squared plus 4x minus 11. I have a quadratic function that looks like this. Let me change it to, let's say, 6. So I have this quadratic function. If I were to find the y-intercept of this function, I could say this is the y-intercept, y equals -11. If I had to find the x-intercepts, I would solve this quadratic equation, and that would give me the x-intercepts of this graph as well. So those two sets of important points, x-intercept and y-intercept, we can find them by either using this constant. This will give us the y-intercept, or if you had to find the x-intercept, we put y equal to 0, solve this quadratic equation, and that's going to give us the x-intercept. So we know how to find those two sets of points now. But there's another important point on the graph that I talked about, and that's the turning point of the graph. And the question is, what if we had to find the turning points of this function? How do we find the turning points of a quadratic function? That is what I want to talk about next. If I have a quadratic function like this, how can I find the turning point of this quadratic function? Let me write that down here. Finding the turning point of a quadratic function. Okay, it could be a U-shaped curve, it could be an N-shaped curve. How do you find the turning point of a quadratic function? Now, the quickest way of doing this would be that if we have a function like this, ax squared plus bx plus c, you can use a formula that looks like this: x equals minus b over 2 times a. This formula is going to give you the x-intercept, sorry, the x-coordinate of the turning point. It's going to give you the x-coordinate of the turning point. And then if you had to find the corresponding y-coordinate of the turning point, what you do is put this value back in the function. Put this value back in the equation to find the corresponding value of y. Now, this is a formula that's going to come really handy to find the turning point. So you should memorize this: x equals minus b over 2a. I'll show you where this comes from in a moment to help you understand this better and also remember this more easily. But this is a formula that we can use directly, minus b over 2a. Now, how exactly is this going to work? Let's take this example for that. Let's say we've got this function, and what we want to do is we want to find the turning point of this function. Okay. How do you find the turning point of the function? We just learned a formula: x equals minus b over 2a. What that means is b is 6 here, right? Let me just write that down on the side. A is equal to 2, b is equal to 6 for this particular function. So what's going to be the x coordinate of the turning point? It's going to be x equals minus b, which is 6, divided by 2 times a, which is 2, and that gives me x equals minus 6 over 4, which is minus 3 over 2, or you can say it's minus 1.5. That's the x coordinate of the turning point. Now, what about the corresponding y coordinate? For the corresponding y coordinate, all I have to do is just input this value of x back in the function to get the corresponding y value of the function. Let's see what that is. y equals 2 into, in place of x, you just put that value, which is negative 1.5 minus 1.5 whole squared plus 6 into minus 1.5 minus 11. And that will give you the corresponding y value of this function as well. Let's see what this turns out to be. 2 into minus 1.5 squared plus 6 times minus 1.5 minus 11. And that is giving me minus 31 over 2 or minus 15.5. That's the corresponding y value that you have. So that means the turning point of this function is minus 1.5 and minus 15.5. Or if you wanted to write this in fractions, this would be minus 3 over 2 and minus 31 over 2. You can write it both ways since in this case, the decimal is an exact decimal. It's not a recurring decimal. It's okay to write this as a decimal as well. And that is acceptable. That's the turning point of this function. Okay. So x equals minus b over 2a. This is going to come in really handy when you're finding the turning points. Okay. And now, in fact, before we discuss completing square method, let me briefly give you an intuition of where this formula comes from. Remember the quadratic formula, minus b plus minus square root of b square minus 4ac whole divided by 2a, right? This was the quadratic formula. Now, basically, that formula minus b over 2a is coming from the quadratic formula. It's just taking this part of the quadratic formula, minus b over 2a, ignoring this part. Now, why is that? Because remember quadratic formula, what does that give us? It gives us the solutions of a quadratic equation, right? And the solutions I just told you, they represent x-intercepts of the graph. So if I had a quadratic function like this quadratic formula would give me, sorry, where did that go? Yeah. Okay, so if I were to use the quadratic formula, it would give me these 2 points on the graph. It will give me the two x-intercepts. What I'm looking for is the x-coordinate of the turning point, which is exactly in the middle of those two x-intercepts. Why is it exactly in the middle? Because the curve is symmetric. Since the curve is symmetric, the turning point has to be exactly between those x-intercepts. Now, the way quadratic formula works is, it first, this minus b over 2a part first takes you to this exact center of the curve, the midpoint, the central point of the curve. And then when you do plus something, it takes you to the x-intercept on the right side of the center. And when you do minus something, that takes you to the x-intercept on the left side of that center. So if we just get rid of that whole thing after the plus minus, if we just get rid of this part, that basically gives us minus b over 2a. And that just tells us the x coordinate of this point exactly in the middle. So we can find the x coordinate of the turning point just by using minus b over 2a. So now, if you forget this formula, what you have to do is think of the quadratic formula. That okay, this is what the quadratic formula looks like. That's something that every one of you hopefully remembers, right? And then just get rid of this plus minus b square minus 4ac part from that, and you get minus b over 2a. That's how you find the x coordinate of the turning point. That's an easy way to remember this as well. And that's where this actually comes from logically. Okay. So this is a formula that you can use now to find the turning point of any function. All right. Okay. Now, this is one way of doing this, finding the turning point. Now, sometimes what happens is they ask you to convert a function to another form, to a form that we call completed square form. And then using that, you might have to find the turning point, or sometimes you might have to solve an equation using that form as well. Now, let's see how that is going to work. Okay. Now, let's take an example. Let's say you have a function like this. Y equals 2x squared plus 8x. Let's say this is minus 8x plus 15. Or if you make it minus 15 as well. Let me just quickly think whether this is going to work. So it's a U shape, and do we have solutions for this? Yeah, so the solutions are going to exist as well. And the number outside, yeah. Okay, all right. So write this function in the form, or just this, write this expression in the form x squared plus or a into x minus h whole squared plus k. So they want you to write down this function in this particular form. Okay. Now this is called completing square. Completing the square of a quadratic expression. Now, how does this work? There are two ways that we will discuss for completing the square. There's one standard method that most people are generally aware of, what most people generally use, and that looks like this. So we'll talk about this particular method tomorrow, which I'm just hinting you towards. When we take 2 common outside, and then that leaves us with x squared minus 4x inside, and then what we do is we divide 4 by 2, and that gives us 2. We add 2 square here, and we subtract 2 square here. These three terms give us a perfect square. We'll talk about this method in our next class. But there's another method that we can actually use once we remember this formula. So remember this formula, x equals minus b over 2a. In a completed square form, in a form that looks like this, h and k are actually coordinates of the turning point. H and k are actually coordinates of the turning point. H and k is the turning point. If you want to convert something to a form like this, a very quick way of doing that does not involve a very complicated calculation as well, is that you find the turning point first, and then in place of h and k, you input the values, the coordinates of that turning point. So let me show you how that works. So you've got this expression. How do you find turning point of a quadratic expression like this? We know the formula for that, x equals minus b over 2a. What is that going to give us? Minus into minus 8 divided by 2 times 2, right? Because in this form, a is equal to 2 and b is equal to minus 8. So we get minus into minus 8 divided by 2 times 2. And that simplifies to 8 over 4, which is 2. That means the x coordinate of the turning point is 2. Okay. Then what about the y coordinate of the turning point? We put this value of x back in the function. What does that give us? 2 into 2 squared minus 8 into 2 minus 15. What do we get from this? 8 minus 16 minus 15. I'll just do this here. 8 minus 16 minus 15, that is minus 23. So y is equal to minus 23. Now the coordinates of the turning point therefore are, 2 and negative 23. Now this is basically h and this is k in this completed square form. And now you can write down the completed square form for this. And that will look like this, that a in this form, so a in this form, ax squared plus bx plus 4, and a in this form, they are both the same. So all you have to do is write down this form like this, a into x minus h whole square plus k. What's the value of a from there? A is equal to 2, so that's 2. In place of a, you put 2. And then x minus h, what's h? H is equal to 2, you put 2 in place of h here. It becomes x minus 2 whole squared. K, what's the value of k that we've got? The value of k is negative 23. So this becomes negative 23 outside. And this is this expression converted to completed square form. Okay. Now, when you do it this way, you basically can do this without taking that number common outside. You can do it without um, doing that complicated plus square something minus square something and then converting that to completing square form. That other method becomes especially complicated when you have fractions involved and when you have to divide fractions by some numbers. If you remember minus b over 2a method, if you remember this formula, all you have to do is just find the turning point using this formula. Once you have the turning point, you would just input that in this form, a into x minus h whole square plus k, and you would get the completed square form for that. Okay, let's take another example. Let's take an example that's a bit more complicated. So in this case, we had to convert it to this form, right? Now, let's say they change it slightly, and they want you to write another function which looks like this, for instance, 4x squared minus 9x plus 12. We want to write this function in the form a into x plus b whole squared plus c. Now, it is possible that they change the names of these letters, change these letters here. So earlier we had x minus h whole square plus k outside. Now they're using some different letters. We've got a, b, and c here. And also earlier we had a negative sign here, a positive sign outside. Now they have a plus sign here, a plus sign here. All of that does not make a difference. Okay. Plus minus, they can be different in our final form, and that doesn't matter. For instance, in the previous example, they had plus k here, we got minus 23 at the end, and that's perfectly okay. That does not make any difference. They can be different. Okay. Now, how do you convert it to this form? The process is going to remain the same process as before. What you have to do is you have to remember the standard completed square form. So basically, this is one form for quadratic functions, ax squared plus bx plus c. This is what we mostly use in most cases. The completed square form looks like this, a into x minus h whole square plus k. Now, no matter what they give in the question, if the plus minus signs are different, it doesn't matter. If the letters are different, we're using h and k, they're using b and c. Again, it doesn't matter. Don't worry about that. All you have to do is remember that this is one standard form and this is the completed square form. We have to remember it like this. It's a into x minus h whole square plus k. In this particular form, h and k, when you have this form, h and k represent the turning point. Once you remember this form, now finding that completed square form is fairly straightforward. All you have to do is find the turning point first of all. So What's the turning point? This is the form that you have right now, 4x squared minus 9x plus 12. Find the turning point from this form, x equals minus b over 2a. What do you get from that? Minus into minus 9 divided by 2 times 4. What's that? That is going to be 9 over 8. Okay, that's the x coordinate of the turning point. Find the corresponding y coordinate, 4 into 9 over 8 whole squared minus 9 into 9 over 8 plus 12. Put this on your calculator and see what that gives you. See the corresponding value of y that you're getting. 4 into 9 divided by 8 whole squared minus 9 into 9 divided by 8 plus 12. And that is giving me 111 over 16. Okay, that's the y coordinate of the turning point. Now, this is the value of h that I have. This is the value of k that I have. The coordinates of the turning point. And this is the value of a. So we've got a. We can put that a in place of a here in the other form. We've got h, which is 9 over 8. We can put that in place of this h here. And we've got k, which is 111 over 16. We can put that in place of this k here. And we would get that completed square form. What does that look like? It's 4 into x minus h, which is 9 over 8, whole squared plus k, which is 111 over 16. And that is the completed square form that we were looking for. This is what we wanted. Now, even though they had plus here, we have minus here. That does not make any difference. Apart from that, it's the same form. And that is what we were looking for. So how do you complete the square for any quadratic expression now? What you have to do is remember this form, memorize this form. This is the standard completed square form, a into x minus h whole squared plus k. A is going to be the same as the a in this form. That's 4 in this case. H and k are the coordinates of the turning point. Find the turning point using the minus b over 2a formula. Find the x coordinate, find the corresponding y coordinate. Put those values of h and k in the function, and that will give you that completed square form. Okay. Now, in the next class, we will learn another method for completing the square. That's what is more common. We'll discuss that as well. And then you can decide which one you want to use after that. And once you have completed the square using these forms, we will see how we can solve equations using these completed square forms as well. So a lot of times what they do is they ask you to complete the square in one part of a question, and then in the next part, they want you to solve that quadratic equation. We will see those examples in the next class. But for now, that's it. I'll see you again in the next one. If you have any quick questions, you can let me know. Any quick questions? All good? All right, so tomorrow we want to complete this, and in addition to this, tomorrow means whenever we have our next class, that's Monday. So we will complete the quadratics part of algebra, and we'll also talk about how to deal with simultaneous equations, how to solve simultaneous equations. Okay, so that's what you want to do next. That's it for today. I'll see you again in the next class. I'll post the recording as well. Make sure that you are submitting the worksheet. The worksheet for factorization. I'm not sure if I uploaded that or not, but I'll do that today. In addition to factorization, I'll also upload another worksheet on quadratics. Please make sure that you take this weekend, attempt most of the questions from all the worksheets, because practice is extremely important, and you have to do that regularly. And you should not be left behind. Otherwise, catching up becomes a bit difficult. All right, so please make sure to attempt questions from the worksheet. I'll see you again in the next class. Allah Hafiz.
Allah Hafiz, sir.
Okay.